Physics. Chapter Heat. In this video you will learn about definition of heat, change of one state to another due to heat, effects of heat, thermal expansion, types of thermal expansion, basics and definition of evaporation and boiling.
Now let us understand the basics. Our experiments and about our daily observations regarding heat. What do we mean by heat in our daily life? Actually, heat is a form of energy which gives us the sensation of feeling the hotness or coldness of the body. States of matter. You must be knowing that there are three states of matter, mainly solids, liquids, and gases, but do you know how can their state of matter can be changed? It can be changed by absorption or rejection of heat, applying pressure externally, etc. Now let us learn about what are the effects of heat. Number 1. Change in temperature of body. Number 2. Change in state of matter of the body. Number 3. Change in size of the body. Now here is a table regarding the change in state of matter of the body. Here, pointing rightwards, the state of matter changes on heating accordingly. And pointing leftwards below, the change of state of matter changes on cooling. Now when a solid, like ice, is heated, it changes into liquid state. The change of the solid state to liquid state on cooling is known as melting. When a liquid is heated, the liquid state changes into the gaseous state and the process is known as vaporization. Now let us go to reverse. When the gas is cooled or, when it is condensed, it changes into liquid state. The change of gaseous state to liquid state on cooling, or by rejection of heat by the body, is known as condensation. When the liquid is cooled, it changes back into the solid state, and the process is known as freezing. Now, if we heat a sublime solid, then what will happen? Will it directly change from solid to gas? Yes. Exactly, it will obviously change directly from solid state to gaseous state, and the process is known as sublimation. For example, when we burn camphor or some naphthalene balls is kept in a hot place, it will directly change into vapor. And the reverse will happen when the sublime gas is cooled. It will directly change from gas phase to solid phase without going to the liquid phase. The process is known as deposition or solidification. Expansions due to heat. When heat is supplied to a body or rejected from an object, the intermolecular forces increase when heat is absorbed, or decrease when heat is rejected. Their molecular space changes as well as their size and shape changes. Thus this increases or decreases the size of the body depending upon heat accepted or rejected by a body. This phenomenon is also known as thermal expansion. When heat is supplied to a body, its molecules gain sufficient energy and start vibrating about their mean positions, and then they start moving randomly. Thus, this increases the intermolecular space and decreases intermolecular force of attraction. Important fact: when there are two bodies, one hot and other less hot, close to each other, the heat passes from hot body to a cold body to make both the bodies at same temperature. For an example, if there are two bodies, one 45 degrees Celsius and other 35 degrees Celsius, the body with 45 degrees Celsius will supply heat to other cooler body and make both the bodies same 40 degrees Celsius. What do we mean by the thermal expansion? Thermal expansion is a process in which when heat is supplied to a body, its space between molecules increases and the body starts expanding in all directions. There are three types of thermal expansions, based on the expansions in the dimensions. Number 1. Linear expansion, the expansion of solids through its length only. Example, increasing in length of iron rod while heating. Number 2. Cubical expansion, the expansion of solids, liquids, and gases through its volume. Example, expansion of liquids like mercury on heating. Number 3. Superficial expansion, the expansion of solids from its area or dimensions. Size increases from its length as well as from its breadth due to heat. For example, expansion of a thin iron sheet on heating. Exceptions of thermal expansion. There are some exceptions of thermal expansion in which some substances do not expand while heating, such as, first, water from 0 degrees Celsius to 4 degrees Celsius. Instead of expansion of water on heating between 0 degrees Celsius to 4 degrees Celsius, it contracts. Then after 4 degrees Celsius water expands. Second, silver iodide on heating between 80 degrees Celsius to 141 degrees Celsius. These can be also termed as anomalous behavior of some substances. Coefficient of thermal expansion. Now what do we mean by coefficient of thermal expansion? Coefficient of thermal expansion is a measurement of the amount or size of expansion, due to heat, in particular bodies. It is measured in units such as alpha. It is the coefficient of amount of expansion, in linear expansion. Beta is the coefficient of superficial expansion, and gamma is the coefficient of cubical expansion.
Exceptions in coefficient of thermal expansion. There are some solids which expands very less, or negligible on heating. The reason is that their molecular forces are very strong and it can't be expanded by heating. Examples, Pyrex glass, Invar, etc. These substances do not expand or expand the least while heating.
Pyrex glasses are used in kitchen appliances and in kitchen rooms for their least expansion while cooking, and for not being broken. Using Invar, the length of the pendulum of a clock don't change and therefore, the time remains always correct. Important fact. We don't feel any changes when we hold an hot solid object, which is still expanding intermolecularly. The reason is that it is expanding equally and throughly in every dimensions. We can feel the expansion only in the form of heat supplied by the object to our hands. Now let's take an example. Here is an solid block made up of iron. This is its original or initial length, and it is heated, and here is the length after expansion. Then, this is the length after heating, and this is the increased length, in the same way. The breadth and height also increase equally and we don't feel the vibrations of the molecules externally when the volume of the iron block expands. Now what is evaporation? The term evaporation Evaporation is a type of vaporization that occurs on the surface of a liquid as it changes into the gas phase. Evaporation is mainly a surface phenomenon in which the water evaporates from the liquid surface. Now here is the picture of evaporation of water in water cycle. The term vaporization. Vaporization refers to conversion of a substance from the liquid phase into the gaseous or vapor phase. If conditions allow the formation of vapor bubbles within a liquid, the vaporization process is called boiling. Vaporization is not an surface phenomenon. The change of liquid to gas changes faster and takes place throughout the whole liquid at a time, at a particular temperature only, which is known as the boiling point of the liquid. Now let us have an comparative study between evaporation and boiling. Here is the table differentiating between evaporation and boiling. Just read it out. Important fact. Evaporation mainly occurs naturally, but in vaporization or boiling, it is not natural. In vaporization we have to externally supply the heat to the liquid at a fixed temperature. Now we have came to the end of the chapter. Thank you for watching. Please like, subscribe and share.